Imagine standing on the edge of the universe's greatest mystery, an object so powerful that not even light can escape its grip. An invisible monster in space, bending time, swallowing stars, and reshaping galaxies. These are black holes. But beyond their terrifying reputation, black holes may hold the key to something even more astonishing, the possibility of portals to another universe. Let's begin with the basics. What exactly is a black hole? In the simplest terms, a black hole is a region of space where gravity has become so strong that nothing, not light, not matter, not even the fastest particles in the universe, can escape. This happens when a massive star, many times larger than our sun, exhausts its fuel. Without the energy to support itself, the star collapses under its own gravity. If the star is big enough, this collapse is unstoppable. The result is a singularity, a point of infinite density, wrapped inside an invisible boundary known as the event horizon. The event horizon is the ultimate one-way door. Once you cross it, there's no coming back. Time, space, and the laws of physics as we know them begin to break down. But here's where things get truly mysterious. Some scientists believe that beyond the event horizon, inside the singularity, reality may not end. It might transform into something else. Could it be a gateway, a tunnel, a bridge to another universe? To understand this possibility, we need to dive deeper into physics. In the early 20th century, Albert Einstein's theory of general relativity described how massive objects warp the fabric of space-time. According to this theory, if gravity becomes infinitely strong at the singularity, space-time could potentially fold in extreme ways. Mathematicians working with Einstein's equations found strange solutions, wormholes, also known as Einstein-Rosen bridges. A wormhole is like a cosmic shortcut. Instead of traveling millions of light-years across the universe, a wormhole could, in theory, connect two distant points in space instantly. Imagine drawing two dots on a piece of paper and folding the paper so the dots touch. This is how a wormhole might connect regions of the cosmos. Now, here's the catch. Many physicists believe black holes could be the entrances to such wormholes. The question is, where do they lead? Some theories suggest that on the other side of a black hole could be a white hole. A white hole is the opposite of a black hole. It pushes matter and energy out instead of pulling it in. If black holes and white holes are connected through a wormhole, then every black hole in our universe could be a doorway to another region of space, or perhaps even an entirely new universe. But before we get carried away, let's slow down and ask, is there any evidence? Right now, the truth is, we don't know. Black holes are incredibly difficult to study because we can't see them directly. They don't emit light, but we can observe their effects. For example, when a black hole consumes nearby matter, the material spirals inward, heating up to millions of degrees and releasing powerful X-rays. Astronomers can detect these X-rays, revealing the presence of the hidden monster. One of those questions is, what happens to the matter that falls in? According to classical physics, once matter crosses the event horizon, it's lost forever. But according to quantum physics, information can never truly disappear. This leads us to the famous black hole information paradox. If black holes destroy information, then our understanding of physics is incomplete. Some scientists, including Stephen Hawking, suggested that black holes might not completely destroy information. They might release it in strange ways, or perhaps send it elsewhere. And elsewhere could mean another universe. Let's take a moment to imagine this. Suppose you fell into a black hole. First, you would experience something called spaghettification. The gravity near a black hole is so extreme that it stretches objects apart. Your feet, closer to the hole, would be pulled faster than your head, stretching you like spaghetti, To an outside observer, you would appear to slow down, frozen at the event horizon. But to you, time would feel normal as you fall. The deeper you go, the stranger it gets, until you reach the singularity where the known laws of physics collapse. If that singularity is connected to a wormhole, you might not be destroyed. You might emerge somewhere else, perhaps in another part of our universe, or in a parallel universe entirely. Parallel universes are not just science fiction. Modern physics, especially theories like string theory and the multiverse hypothesis, suggest that our universe might be just one of many. In this framework, black holes could act as cosmic gateways, linking universes like beads on a necklace. Imagine billions of universes, each with different laws of physics, connected through black holes. It sounds wild, but mathematically, it's not impossible. However, there are big problems. Wormholes, if they exist, would be unstable. The intense gravity would cause them to collapse instantly. To keep a wormhole open, scientists theorize that you would need something called exotic matter, a strange form of matter with negative energy density. Exotic matter has never been observed, but quantum physics doesn't rule it out. If we could find or create it, wormholes might become traversable. So where does this leave us? Right now, black holes remain mysterious. We know they exist, we know they shape galaxies, and we know they hold the answers to deep questions about space and time. But whether they are portals to another universe, well, that remains one of the greatest cosmic mysteries of all, and we've only scratched the surface. In the next part, we'll explore some of the mind-bending possibilities. Could traveling through a black hole allow for time travel? Could advanced civilizations use them as shortcuts across the cosmos? And most importantly, what would it mean for us if black holes really are gateways to other universes? In part 1, we explored the basics of black holes, their event horizons, the possibility of wormholes, and the idea that they might connect to other universes. Now, let's push deeper into the possibilities and the problems that come with this cosmic idea. One of the most fascinating possibilities is time travel. Black holes don't just bend space, they also warp time itself. Near a black hole, time flows differently than it does far away. This is not just theory, it's been proven. Astronauts orbiting close to a black hole would experience time more slowly than people farther away. This effect, called time dilation, means that someone spending only a few hours near a black hole could return to find that years, or even centuries, had passed elsewhere in the universe. In a way, black holes could be natural time machines, but could they also let us move backward in time? The equations of general relativity suggest it might be possible. Wormholes, if they connect two different regions of space-time, could in theory connect different points in time as well. Imagine entering a black hole and not only arriving in another place but another era. Could black holes be the secret to time travel that humanity has dreamed about for centuries? Some physicists think it's possible, at least mathematically. Others warn that paradoxes would make it impossible. After all, what happens if you go back in time and prevent yourself from falling into the black hole in the first place? Let's go even further. Could advanced civilizations, far beyond our technology, already be using black holes as gateways? Science fiction often imagines alien civilizations harnessing wormholes as cosmic highways, moving instantly across galaxies or even between universes. To us, black holes look like destructive monsters. But to a civilization millions of years ahead of us, with control over exotic matter and energy, they might look like doors, tools for exploration. This idea isn't completely far-fetched. After all, we humans once looked at the oceans as barriers. Today, they are highways. What if black holes are the oceans of the cosmos and we're just not ready to sail them yet? Another incredible idea is that our own universe may have been born from a black hole. Think about it. The Big Bang, the event that created everything, was a singularity, a point of infinite density, just like the core of a black hole. Some cosmologists suggest that when a black hole forms, the singularity doesn't just collapse endlessly. Instead, it could bounce and expand into a new universe, sealed off from ours. If this is true, then every black hole in our universe might be a cosmic seed, planting new universes beyond our reach. This would mean that our universe is not alone. It's part of a vast multiverse, connected by the births of black holes. But as exciting as this sounds, we must face the limits of our knowledge. The biggest challenge in understanding black holes is the conflict between general relativity and quantum mechanics. Relativity explains gravity and the large-scale structure of the universe. Quantum mechanics explains the tiniest particles and their strange behaviors. Both theories work brilliantly in their own domains, but when you apply them together inside a black hole, they clash. The math breaks down. It's as if the universe is hiding its deepest secret behind a locked door, and we don't yet have the key. This is why scientists are searching for a theory of quantum gravity, a single framework that unites relativity and quantum mechanics. If we find it, we might finally understand what happens inside black holes, and whether they connect to other universes. The search is ongoing. From string theory to loop quantum gravity, from simulations on supercomputers to experiments at particle accelerators, scientists are trying to crack the code. In 1974, Stephen Hawking shocked the world with his discovery of Hawking radiation. He showed that black holes are not completely black. They slowly leak energy, and over unimaginable time spans, they evaporate. If black holes eventually vanish, what happens to everything they swallowed? Does the information reappear? Is it scrambled into Hawking radiation, or does it escape into another universe? Hawking himself wrestled with this question until his death, leaving behind one of the greatest puzzles in physics. For now, we stand at the edge of knowledge. We can observe black holes indirectly, we can simulate them in equations, but we cannot enter them or see what lies beyond. They are the ultimate mystery, part terrifying, part fascinating, and completely unknown. Let's reflect for a moment. If black holes are portals, then the universe is far stranger than we ever imagined. Our night sky, filled with stars, would also be filled with gateways, millions of possible doorways to other realms. Somewhere out there, a star collapses into a black hole, and at that very instant, perhaps a new universe is born. Maybe, in another universe, another version of you is asking the same questions. And yet, maybe black holes are not portals at all. Maybe they are simply cosmic graves, the end of matter, the end of time. Either way, they challenge us to push beyond our limits, to ask bigger questions, and to never stop searching for answers. So, are black holes portals to another universe? The truth is, we don't know. But in that uncertainty lies something even greater: possibility. Black holes are not just monsters in the dark. They are cosmic invitations, urging us to explore, to imagine, and to dream of what lies beyond. The next time you look up at the stars, remember, hidden among them are the most mysterious objects in existence. They could be the universe's dead ends or its doorways. The adventure of discovery has only just begun.